In this video, we're going to look at joint cases on small and great circles. Number 1. A. Latitude 43 degrees north, longitude 77 degrees east. B. Latitude 43 degrees north, longitude 103 degrees west. And C. Latitude 57 degrees south, longitude 77 degrees east are 3 points on the surface of the Earth. Find the distance from 1. A to B along latitude 43 degrees north, A to C along the great circle joining the 2 points. Let's draw a diagram. Okay. The point A is latitude 43 degrees north. So it's latitude 42 degrees north and 77 degrees east longitude. There is longitude 77 degrees east, north south, east west. So this point A, and B is latitude 43 degrees north on the same latitude but 103 degrees west. So this is longitude 103 degrees west, and this is point B. So points A and B are on the same latitude. So this is the center of latitude and small circle. The radius of the small circle. Okay, so connect the 2 points A, B. So let's call this the center C. And so as C is latitude 57 degrees south, longitude 77 degrees east. And so C, this is point C. And now points A and C are on the same line of longitude. That's a great circle. So question says, calculate, find the distance from A to B along latitude 43 degrees north as on along the parallel of latitude 43 degrees north. That is a small circle. So on figure 1, we have this shape. So this is E, this is B. So A is longitude 77 degrees. B is longitude 103 degrees. The total is the angular difference and the difference theta is equal to 103 degrees plus 77 degrees. Now different sides of the globe. So and that will give us on 80 degrees. So the total angle is 180 degrees. Next is distance between AB along latitude 43 degrees. Along latitude 43 degrees north is equal to theta at 60 degrees times 2 pi rcos alpha, and that will give us 180 degrees over 260 degrees times 2 pi is 3.142. 3.142 r is 6,400 times cos 42 degrees. This is 180 and 1, 180 is 2, 3 and 1, 3 and 1. So 3.142 times 6,400 times cos 42 times 1,147,706.65 kilometer approximately. So three significant figures: 1, 2, 3, 1, 4, 7, 14,700 kilometers. So three significant figures. Number 2 says A to C along the great circle joining the 2 points. So it's A to C on the great circle because the 2 points are on the line of longitude. So distance A C along the great circle equal to theta or 360 degrees times 2 pi r squared. So A to C as longitude A, latitude A is of A is 42 degrees north, difference 43 degrees. Latitude C 67 degrees south, 57 degrees. The angular difference that's difference in latitude. Angular difference theta is equal to 43 degrees plus 57 degrees. 43 plus 100 degrees. So we have a distance AC is equal to 100 degrees or 60 degrees times 2 times 3.142 times 6,400. So 100 times 2 times 3.142 times 6,400. 4021760 like 260 degrees. 11171.56 kilometers. So let's see significant figures: 1, 2, 3, 11200, 11,200 kilometers. So very significant figures. Two points P and Q on latitudes 40 degrees south are on longitude 15 degrees west and 40 degrees west respectively. So 2 points P and Q on latitudes 40 degrees south. So longitude 15 degrees west. So 15 degrees west. And that's point P. Point Q is on latitude 45 degrees west. So longitude 45 degrees. Longitude 45 degrees west. So this point Q. Point Q. And both points are at altitude and this latitude, and the center is from here. Connect these 2 points. So this is a small circle that we have here. So from P for 40, P is 15 degrees, and Q is PQ. So Q is 45 degrees. So the truth from therefore Q to P is below 1. So find the distance between P and Q along the parallel of latitude. So 1A, E, angular distance, angular difference, angular difference, which is theta, is equal to 45 degrees west minus 15 degrees. So we're subtracting because both P and Q are on the same side of the globe in the southern hemisphere, and western on the west. So 45 degrees minus 15, that's 30 degrees. So that's 30 degrees. So distance PQ along the parallel of latitude, as this PQ is a small circle, so theta to 60 degrees, then 2 pi r cos alpha. Theta is equal to 30 degrees, where 60 degrees times 2. Pi is 20/7, and r is 6,400 times cos. Alpha is the common line of latitude, cos 40 degrees. And the line of latitude is the line on which the 2 points are aligned. So 3, 31, 30, 12, 2 here 1, 2 here 6, 2 here 11, 2 here 3. So 11 times 6,400 times cos 40 . Over 21. So the question says to the nearest 100 kilometers, correct to the nearest 100 kilometers. So this unit is 10 is 100. So 2, 6, 2,600 kilometers. So the nearest 100 kilometers. B. This says a third point R is on the same longitude as Q. That's on longitude 45 degrees west as Q, but due north of it. So the third point is due north of it. So let's put R going towards due north. Point R is but due north of it. If the distance between Q and R is 6,700 kilometers. Now find the total time taken by an aircraft which flies at a constant speed of 850 kilometers per hour from P to Q and then to R. So B1, Roman figure 1, speed is equal to distance over time. So we're given time. We are going to look for the time. So time is equal to distance over speed. So time is equal to, now distance from the question says find the total time taken by an aircraft which flies at a constant speed of 850 kilometers from P to Q. So we're going to look for the distance from P to Q and first, So okay, so the distance is from P to Q. Yes, PQ plus, and then from P to Q and then to R. So P to Q, then Q to R. P to Q plus Q to R over speed. So it's time. So distance between P to Q is what we are gotten in E. So 256.07 plus distance from Q to R is given here, which should be is given here. Okay, a third point R is on the same globe. So the distance between Q and R is 6,700 kilometers. 6,700 divided by the speed 850. So that would give us 2,2568.77 plus 6,700. 9268.77 divided by 850. 10.9 hours. So that's 10.9 hours. That's the time taken to fly from P to Q and then to R. So once you got through, what is the latitude of R? Okay, since since R is on the same longitude as Q, that means Q and R on a great circle. The distance between Q and R is on a great circle. So to look like this. That's what is going to have a great circle. So I'm going to have here. Alright. So this is Q and this is R. And then we're going to have, so latitude Q is 40 degrees south, 40 degrees, and latitude R. So I'm going to say let's the latitude of R be x degrees. Since it's due north, x degrees north, that's x degrees. So angular difference is equal to, so look at it. Now what we observe is that from Q, since it's moving Q naught, is x plus 40 degrees plus x. 40 degrees plus x. So distance QR is equal to, distance QR is on a great circle. So it will be theta over 3 60 degrees times 2 pi r. And distance QR is going to be, QR is 6,700 kilometers. 6,700 is equal to 40 degrees plus x, because it's addition, because Q is on the south and R is due north. So the latitude of R, which is on a different hemisphere, Q is on a different hemisphere. So 40 degrees plus x over 60 degrees times 2 times 22 over 7 times 6,400, and this will give us 6,700 equal to 2 times 22 times 6,400. So it's 281,600. So 40 degrees plus x, 281,600 divided by, so this 360 degrees times 7 will give us 2520. So what we have there is 6,700 equals to 40 degrees plus x, 281,600 over 2520, cross multiplying, just multiplying 40 degrees plus x 281,600 equals to 6,700 times 2520. So 40 degrees plus x 281,600 is equal to 6,700 times 2520. 16884 16884,000. So 40 degrees plus x equals to 16884,000 over 281,600. 40 degrees plus x equals to divided by 281,600. 168.5 59.96. So 40 degrees plus x equals to 59.96. So x is equal to 59.96 degrees minus 40 degrees. And x equals to 59.96 minus 40. X is equal to 19.96 degrees. X approximately 20 degrees north. Therefore, the latitude of R is 20 degrees north. The longitude of town B is 48 degrees east, and the longitude of town C is 32 degrees west. Both towns B and C lie on latitude 25 degrees north. So let's represent this in the diagram. Okay, so longitude of town B is 48 degrees east. This is the east. Longitude 48 degrees east, north, south, west. And town C is 32 degrees west. Longitude 32 degrees west. 32 degrees west. Alright. And both B and C lie on latitude 25 degrees north. This is latitude 25 degrees north. So this line of latitude has a center, which is this. So this is point B and this point C. Alright, so from the center, connect the 2 points. So, okay. Now the next thing is this one says find the distance between town B and C along the parallel of latitude. So we have the shape. This is C and this is B. Longitude B is 48 degrees east, 48 degrees. Longitude C is 32 degrees west. So angular difference theta is equal to 48 degrees plus 32 degrees. B is on the east and C is on the west. So we add the angular difference. 48 plus 32 that's 80 degrees. 80 degrees. So 80 degrees. Now distance BC along the parallel of latitude. Along the parallel of latitude, that's distance, small circle distance. So to theta about 360 degrees. Theta about 360 degrees times 2 pi r cos alpha, and this will give us 80 degrees over 360 degrees times 2 pi is 3.142. 3.142. 6,400 times cos 25 degrees. So this will give us 80 times 2 times 3.142 times 6,400 times cos 25, 291,5961.924 divided by 360 degrees divided by 360 degrees. So 8099.89 kilometers approximately. Correct to three significant figures. So three significant figures. This is the first, this is the second, this is the third. So the next one is 9. Round down, round up, bring 0, add 1 to this 9 becomes 10. Rather 0, bring the 1 over here, so it becomes 8100 kilometers to three significant figures. That's 8,100 kilometers. 8,100 kilometers. So 2 says chord BC. So the chord BC is, we say length of chord BC. The same thing. Length of chord BC is equal to 2r sine theta over 2. But r is equal to r cos alpha. So length of chord BC is equal to 2r cos alpha sine theta over 2. And so where r is equal to 6,400 and alpha is equal to line of latitude on which both B and C are lying 25 degrees north. So therefore that's equal to, so we say chord BC is equal to 2 times 6,400 times cos 25 degrees times sine theta. Theta is 100. No, the angular that's 80 degrees and 80 degrees over 2. That will give us 2 times 6,400 times cos 25 degrees times 80 degrees divided by 2 will give us sine 40 degrees. So 2 times 6,400 and cos 25. Cos 25 is 0.9063 times sine 40 0.6428. 2 times 6,400 times 0.9063 times 0.6428. 7,456.89 kilometers. To three significant figures: 1, 2, 3, 7,460 kilometers to two significant figures. B says town A is 4,800 kilometers north of town B. So let's say amount of town B. That is town A is on the same line of longitude as town B. So this is town A. And the distance is 4,800 kilometers north of town B. If the latitude of town B is 25 degrees north, what is the latitude of town E to the nearest degree? So let's, okay, we can say town, so the latitude of town E can be gotten as follows. So now when, so this since they are on the same line of longitude, that's on the great, that's the distance is the great circle route. So we can connect it to the equator. Into the equator. So that's a great circle. So we have something B, E. So E is unknown. So let's say A is x degrees, and B is longitude of B is latitude of B is rather 25 degrees. 25 degrees. So let's the latitude of town A can be gotten as follows. So let's solve for the angular theta. So since the distance is a great circle BA, so distance BA. Now usually I would say x plus 25 degrees in place of theta, but I don't want to put that yet because I need to make an explanation. But I've just said the angular distance be x plus 25 or x minus 25, and put it here x plus 25. Let's solve. But I don't want to do that because I need to make an explanation. Distance BA is equal to theta over 360 degrees times 2 pi r. Okay, so distance is the distance of angular difference, which is the difference between the latitude B and latitude A. So let's go on. So the distance is given to us as 4,800 kilometers. So we have here 4,800 equal to theta over 360 degrees times 2 times 3.142 times 6,400. So 4,800 is equal to 2 times 3.142 times 6,400. 402. So 40217.6 times theta divided by 360 degrees. So what you have there is 4,800 equal to 40217.6 theta over 360 degrees. So cross multiplying 4021.6 theta 360 degrees times 4800 times 360 1728000. So theta is equal to 1728000 divided by 40217.6. Theta is equal to 40217.6. That is 42.97 degrees. Now note theta, since this BA is on the same line of longitude, that means they have both B and A have the same longitude but different latitude. So our angular difference would arise from difference in latitude. So and now one thing we need to know is that, so if the difference in latitude, in other words, since both of them are on the same side of the globe, you're going to subtract the smaller latitude from the bigger latitude. But in this case, we are looking for latitude A, and this theta here is the angular difference. So in other words, theta is supposed to be B, angular difference, which is B minus A minus B. But in this case, since so to get our A, get our A minus B. So A, the first way we can go about it is that from here we'll make A the Soviet formula, latitude of A the Soviet formula, and this will become theta plus beta, theta plus B rather. So A is equal to theta, which is 42.97 degrees, plus beta plus B beta plus B latitude B, which is 25 degrees. So this will give us 42.97 plus 25, that's 67.97 degrees. Or you can say, now another way to do it is that normally, if you're to go by the first way I used to calculate either latitude or longitude, this angular distance, I would say, since this is 25 degrees and this is x degrees, and we have both on this same side of the globe, that means we're going to subtract to get the angular differences. So to get E, we're going to say latitude of A would be B minus A. So okay, we're going to have them subtract this one from A. That's B minus A to get theta, angular difference. Now, but since the latitude of B is given and the aircraft or town B rather, town A is due north of town B, that means it's going towards the North Pole, and that means A is higher than B. So since B is given, and then we've already known, or since B is given, and from our calculation, we're able to know theta, which is the angular difference or the difference in latitude. We're going to add 42.97 to 25 because A is going higher towards the North Pole. So the higher you go, the higher the value. But the lower you go, the lower you come close to the equator, the value of latitude decreases because the latitude, the equator is 0, and that's the reference parallel and the reference latitude. So the higher you go from the equator to the North Pole, the higher the value of latitude, the theta plus beta. So A is equal to 42.97 plus 25 equal to 67.97 degrees. So if this explanation is not clear, then follow this one. This one is straightforward. Angular difference theta, since they are the same on the same part of the globe, you have to subtract. So theta is A minus B. Why? A is higher, B is lower, so the latitude of A will be greater than the latitude of B. So subtract the smaller latitude from the bigger latitude. So A itself, so because we are looking for the latitude of A, we bring this one to this side, it becomes theta plus beta, so we get 7.9 degrees. Why? This one is based on the fact that as we move northward, the latitude will increase to be greater than B. So subtracting A from B will not make sense. Rather, you're going to add B to A. So A equals to theta plus B, you get 7.97 degrees. So therefore, okay, so I'm going to say A is equal to 68 degrees, not approximately, to the nearest degree. That's the answer. An aeroplane flies from town A 20 degrees north, 60 degrees east to town B 20 degrees north, 20 degrees east. So 20 degrees north, latitude 20 degrees north, 60 degrees east. Yes, longitude 60 degrees east. This point, town E. and then total on B 20 degrees north, same on the same line of latitude, but a different line of longitude. This is longitude 20 degrees east. Okay, so this town B. Since both points lie on the same line of latitude, so this is the center of this line of latitude. So both points are the route is a small circle route. So this will give us A, B. So latitude, longitude. A is longitude 20 degrees. Longitude A is longitude 60 degrees. B is longitude 20 degrees. A is longitude 60 degrees. So angular distance. Okay, so now the question says, number one says, if the journey takes 6 hours, calculate correlated to a significant figure the average speed of the aeroplane. The speed is equal to distance. So this figure one. Speed is equal to distance over time. So here we're giving this. We want to look for the distance. No, we also look for the speed of the aeroplane, the average speed of the aeroplane. So average speed for the distance over time. And we're given time, but we're not given distance. So we're going to calculate. We're going to evaluate the distance covered by the aeroplane. Okay, so distance will be gotten from knowing the distance between point A and B. So first of all, we need to know angular difference. Angular difference. Angular difference is 60 degrees minus 20 degrees. And that's 40 degrees. So 40 degrees. And since the both points lie on the same line of latitude, that's distance EB. That's a small circle route. Distance EB along the parallel of latitude is equal to theta over 260 degrees times 2 pi r cos alpha. So theta is 40 degrees or 260 degrees times 2 times pi is 3.142. Radius of the earth is 6,400 cos alpha. Alpha is the parallel line of latitude on which both point A and B are lying, cos 20 degrees. times so 40 here 1, 40 here 9. So 2 times 3.142 times 6,400 times cos 20 37792.18 divided by 9. 199.13 kilometers. And correlated to significant figures, if I add 2, 3, that will give us 4,200 4,200 kilometers. So to reach significant figures, the speed or average speed equal to this total distance covered or total time taken. And now we've gotten the value of distance covered from A to B. Now let's get the speed. So speed is equal to the distance which is 4199.12 divided by time. The time taken is 6 hours. So that will give us 4199.13 divided by 6. 4199.13 divided by 6. 699.855 kilometers. So 3 significant figures. 1, 2, 3. The next one is 8. So round up. To add 1 to the 8 becomes 10, 0. Add 1 to the 1 is 10, 0. So that's 700 kilometers. So 3 significant figures. So 700 kilometers per hour. Okay. 3 significant figures. Then Roman figure. So this is Roman figure 1. Roman figure 2. If it then flies due north from town B to town C, due north from town B to town C. So from this point to somewhere here, let's call that town C because it went due north. Now both B and C are now lying on the same line of longitude, so that would be a great circle route. So the question says find okay, if it then flies due north from town B to town C 420 kilometers away, calculate correct to the nearest degree the latitude of town C. Take radius of the earth 6,400 kilometers. So like I explained in the other example, the last example before this one. Now this point is upward, going towards the north. So when we are by the time we get the value of theta, which is supposed to be the angular difference, let's just say angular difference or difference in latitude theta is equal to, okay, so let's just say theta, angular difference is equal to theta. So by the time we get the value of theta, we would know what to do next. So theta, so assuming the value of the latitude of C is known, what we would have done was that to get the angular difference, we need to subtract, of course, the value here will be larger than this value here because as we go towards the North Pole, the angle of latitude, the value of the latitude of C would increase. That's because parallel of latitude starts from the equator, and the equator is 0. So from here it goes the North Pole is 90 degrees. So it increases as you go towards the North Pole, and then it also increases as you go towards the South Pole. So since C is up or to the due north is above B, that means the latitude of C would be greater than the latitude of B. So in a nutshell, angular difference theta would have been C minus B. So that C is equal to, bring this one here, theta plus B. So just add this at the back of your mind. Alright, so first of all, let me just leave it as theta. So since it's a great circle route, because it's on the same line of longitude, I'll bring it to the equator. Bring this one to the equator. So bring it to the equator. So both points. Okay. So that's it. So now point B, distance BC is equal to theta, which is the angular difference, 360 degrees times 2 pi r. So distance BC is given to us from what we have a 420 kilometers away. 420 is equal to theta times over 360 degrees times 2 times pi is 3.142 times r, radius of the earth 6,400. So 420 equals to 2 times 3.142 times 6,400. That is equal to 4021 7.6 theta around 260 degrees over 1. Cross multiplying we have 420 times 360 degrees is equal to 4021 7.6 theta. So theta is equal to, multiply this together, 420 times 360 is 151 15 and 200 divided by 15 and 200. 15 and 200 divided by 40217.6. So 13 is equal to divided by 40217.6. That's 3.76. So now we've gotten the value of theta to be 3.76 degrees. So what do we do next? So as I explained earlier, theta is equal to, assuming we knew the latitude of C and we're to get the angular difference here, it would have been theta equals to C minus B. That is latitude difference, which is the higher latitude subtract the lower latitude from the higher latitude. So it would have been C minus B. But in this case, we are looking for a latitude of C. So we need to get theta. So C is equal to theta plus B, latitude of B. So now we've gotten the value of theta to be 3.76. So we're going to say C is equal to 3.76 degrees plus the latitude of beta is what? At 20 degrees north. 20 degrees. So this will give us 3.76 plus 20. That is 3.76 degrees. So C is approximately 24 degrees north. So we said therefore the latitude of C is 24 degrees north. Yeah. 24 degrees, approximately 24 degrees north to the nearest degree. An aeroplane flies eastward from a town in 60 degrees south, 40 degrees east for 4 hours at an average speed of 300 kilometers per hour to another town R. It then flies due north from R to another town T, a distance of 1,800 kilometers. Calculate A, the longitude of R, B, the latitude of T, correct to the nearest degree. So an aeroplane flies eastward. Point N is 60 degrees south latitude. So this is latitude 60 degrees south and longitude 40 degrees east. 40 degrees east. This is longitude 40 degrees east. We'll call this point M. Then an aeroplane flies eastward from a town M 60 degrees south, 40 degrees east for 4 hours at an average speed of 300 kilometers per hour to another town R. So it flew eastward. So point R, still on the same line of latitude, but eastward. So let's get this. So we're going to look for the latitude of this point R. Okay, so we have point MR. Then the question says it then flies due north from R to another town T. On this new line of longitude, it flew due north for this direction. So let's say this point C. Okay, point C flew due north. So the question says from here, calculate A, the longitude of R. So A, longitude of R. So to get the longitude of R, whenever we are to look for longitude of R or longitude of a place, it means that the latitude is the same. So as you can see it here, both M and R are lying on the same line of latitude. So the latitude is the same. So the longitude will give us the angular difference. If assuming we know longitude of r, angular difference would have been, since both points are lying on the same latitude, then the angular difference would have been difference in longitude. So that will not give us, now if you look at it, the one that's close to the pole, eastern pole, is, which is E. Okay, by explanation, you discover that when I started, we have a prime meridian from which all longitudes are measured. So prime meridian, any other, as you get away from the prime meridian is 0 degrees. So as you get away from the prime meridian, the farther you go, the closer it gets to 180 degrees. So this point is 180 degrees, this point is 180 degrees. While for parallel lines of latitude, the equator is 0. So the farther you go away from the equator, the closer the value approaches 90 degrees. So if this longitude given to us here is longitude 40 degrees east rather. So the longitude r will be greater than longitude m. So angular difference would have been, which is theta. Okay, I'm reading theta here, would have been r minus m. That's to say you subtract the smaller longitude from the bigger or larger longitude. So theta is equal to r minus m. So let's have this at the back of our minds. But instead of r minus m, I'm just going to put theta first of all to calculate. So distance mr is equal to theta over 360 degrees times 2 pi r cos alpha, because both points are lying on the same parallel line of latitude, and that's latitude 60 degrees south, and that's a small circle route. So this is what you're going to have, small circle route with the center. So this will be, and this is it. So the small circle route. Down distance mr, let's see if it's given to us a distance. So an aeroplane flies eastward from a town M for 4 hours at an average speed of 200 kilometers per hour to another town R. It then flies due north from R to another town T, a distance of 1,800 kilometers. So here we're not giving for 4 hours at an average speed. We're giving the average speed, but we're not giving distance. I think, yeah, we're giving an aeroplane flies eastward from a town. Okay. Oh, so we're going to get the distance from here. But since we're giving speed is equal to distance over time. So which implies that we're not going to make use of this formula yet. We're going to get this distance from, we need distance because we don't know distance and we don't know the angular difference theta. So first of all, we can get distance from this formula. So distance then is equal to speed times time. Speed times time. So the speed is given to us as 300 kilometers per hour. 300 kilometers per hour times time 4 hours times 4, and that is equal to 1,200 kilometers per hour. 400, no, 300 times 4, 1,200 kilometers. So that's the distance from M to R. Now, since we've gotten the distance mr, so we're going to have distance m to r is equal to this formula, theta over 360 degrees times 2 pi r cos alpha. 2 pi r cos alpha. So distance mr is equal to 1,200 is equal to theta, the angular difference, 360 over 360 degrees times pi is 22 over 7 times 2 times 22 over 7 times 6,400 times cos 60 degrees. Cos 60 degrees. And of course 2 here 1, 2 here 180 degrees, 2 here 11, 2 here 90 degrees. So 1,200 is equal to 6,400 times 11 times cos 60, 35,200 theta over 90 times 7, 630. So cross multiplying us multiplying. So we have 35,200 theta minus 630 times 1,200. So theta is equal to 35,200 theta is equal to 630 times 1,200, 756,000. So theta is equal to 756,000 over 35,200. So theta is equal to 35,200. So theta is 21.48 degrees. So the angular difference is 21.48 degrees. I remember I said, okay, it was not here. So now we've gotten theta, which is 21.48 degrees. So if we were to angular difference, okay, this is what I stated. So remember I said angular difference theta is equal to r minus m. And we're told to look for the longitude of r. So assuming the longitude of r was given and we had to look for theta, this was what we would have done. We would have subtracted the smaller longitude from the larger longitude. But now the longitude of m is known, but the longitude of r is not known. I want to find the longitude of r. So the angular difference theta is equal to, we say but theta is equal to r minus m. Now make r the subject formula. R is equal to theta plus m. So r is equal to 21.48 degrees plus the longitude of m, which is 40 degrees. 40 degrees. So r is equal to 21.48 plus 40. That's 61.48 degrees. So therefore, okay, let me say approximately r is approximately 61 degrees east. 61 degrees east. So the nearest degree. So therefore, the longitude of r is 61 degrees east. D. Now this says the latitude of t. So we're going to look for the latitude of t. Now latitude is usually the angular difference when 2 points are on the same line of longitude. That is to say, the distance between 2 points is on a great circle route. So as it is, because these 2 points are on the same longitude, this is a great circle route. So if we were to get the assuming the latitude of t is known, the angular difference would have been, so the angular difference would have been the difference in latitude, because the longitude will be common to both points. So theta would have been now in this case. So they are on different sides of the globe. So this is t on the north and this is r on the south. So what would have happened is that it will be r, longitude of r, so the latitude of r plus the latitude of t. That is theta is equal to r plus t. So we want to look for the latitude of t, whereas the latitude of r is known, which is latitude 60 degrees south. So let's look for theta first of all, then we make sure of this equation. So distance RT is on the great circle. Distance RT is equal to theta over 260 degrees times 2 pi r. So and distance RT from the question is 1,800 kilometers. So 1,800 is equal to theta over 260 degrees times 2 times 22 over 7 times 6,400. Okay, so 2 here, 2 here is equal to 180 degrees, 2 here, 11, 2 here is 90 degrees. So 1,800 is equal to 11 times 6,400, 7,400 theta over 90 times 7 is 630. So cross multiplying, we're going to have 1800 times 630 is equal to 70400 theta. So theta over here, so theta is equal to 1800 times 630 equal to 1133400 over 6 over 70400. So theta is equal to divided by 70400, 16.11 degrees. So the angular difference is 16.11 degrees. Now remember that if assuming C was known initially, since both points are on the same line of longitude, the angular difference would have been difference in latitude, and that would have meant that since T is on the northern hemisphere and R is on the southern hemisphere, it would have meant that to get angular difference, you needed to have added R plus T. So following that, we say but theta is equal to R plus T. And now we're looking for the latitude of T. So T is equal to R minus theta minus R. So but T is equal to R minus theta. So T is equal to the latitude of R. The latitude of R is 60 degrees. 60 degrees minus 16.11 degrees. So T is equal to 60 minus 11 point, no, 60 minus 16.11, and that's 43.89 degrees. So T approximately is equal to 44 degrees. Since T is due north, it's going to be 44 degrees north. So therefore, the latitude of T is 44 degrees north. 44 degrees north to the nearest degree. A plane flies due east from A, latitude 53 degrees north, longitude 25 degrees east, to a point B, latitude 53 degrees north, longitude 85 degrees east, at an average speed of 400 kilometers per hour. The plane then flies south from B to a point C, 2,000 kilometers away. Calculate correctly the nearest whole number. A, the distance between A and B. B, the time the plane takes to reach point B. C, the latitude of C. Oh my shape is not perfect. Okay. Right. Alright. So point A is latitude 53 degrees north. Latitude 53 degrees north. Longitude 25 degrees east. Longitude 25 degrees east. So this is point A. And so point B, latitude 53 degrees north, same latitude, longitude 85 degrees east. So this is longitude 85 degrees east, point B. So since both points are lying on the same line of latitude, that's a small circle route. Right. So this is the center of the small circle. Let me use M. M is the center of the small circle. The radius of the small circle. Like a small circle. So then, at an average speed of 400 kilometers per hour, so the plane then flies south from B to a point C, south. fly south from B to a point C. So let's say this is the point C is on the same line of longitude. So, and 2,000 kilometers away, calculate. So this all the information selection. A says the distance between A and B. So for A and B, we have something destination. We have this is B and this is A. So A is longitude 85 degrees. A is longitude 25 degrees east, 25 degrees, and B is 85 degrees. So we need to do here. So A, angular difference theta is equal to, since both A and B are on the same side of the globe, the east, that means we're going to subtract the longitude, subtract the smaller longitude from the larger longitude. 85 degrees minus 25 degrees. 85 minus 25 is 60 degrees. So distance AB along the parallel of latitude 53 degrees north is equal to theta over 260 degrees times 2 pi r cos alpha. Okay. So theta is 60 degrees over 260 degrees times 2. Pi is 22 over 7 times r is 6,400 times cos 53 degrees latitude, 53 degrees north, 53 degrees. So 60 times 2 times 22 times 6,400 times cos 53 is equal to 101,682,666.63. 360 degrees times 7 will give us 2,520. 281,600 theta 504,0000. So theta is equal to 504,000 divided by 281,600. So theta is equal to 504. 17.90 degrees. But theta is equal to B plus C. But theta is B plus equal to B plus C. Theta is equal to C. Okay, B plus C. But so now we want to know the latitude of C. So C is equal to B minus theta. So C is equal to B. Latitude of B is 53 degrees. 53 degrees minus that of theta is 17.90 degrees. So C is equal to 53 minus 17.90. That's 35.10 degrees. So C approximately is 35 degrees south. So the nearest whole number. So therefore the latitude of C is 35 degrees south.